In this video, I picked out a 10-mark, pretty difficult exam question on mechanics. So this focuses on projectile and it is year 2 A-level maths. So if you're in year 1, I maybe advise not doing the question, but you can still have a look at it. So it would help a lot if we draw things out. So I'm going to draw our axes with the point O at the origin. It tells you it's projected with an initial speed of u. So let's write that out. A speed of u meters per second. And an angle of theta above the horizontal. It tells you at time t, its position will be at xy. So let's represent that randomly on a diagram because it's going to help us visualize things later on. Relative to the origin, that's just a fancy way of saying this is the coordinate when this is the origin. It says write down expressions for x and y at a time t. In order to do that, okay, and it says hence derive the Cartesian equation. Let's break it down into two parts. Let's first find x and y in terms of t. So to find x, we're going to look at the horizontal motion. Now, what can we assume horizontally for any projectile? We can assume that acceleration is 0. Now, why that's important is there's an equation, which I'm just going to write out to this side, s equals ut plus a half at squared. But if acceleration is 0, that means that this whole second part of the expression, half at squared, is also equal to 0, meaning you're just left with s equals ut, which is just a way of saying that the horizontal distance traveled, which I'm going to call sh, so h just refers to horizontal, is the horizontal speed that's traveled, so UH multiplied by the time taken to reach that point, if that makes sense. Now we can find the horizontal component of the velocity by splitting this up into a right angled triangle and using SOHCAHTOA, so let's do that. So if we draw a right angled triangle out, we have U is the hypotenuse of the triangle, we have this is the angle theta, and we're interested in representing the horizontal part. Let's do that in a different color, maybe red. So let's call this UH. Because we're not interested in the opposite, but we are interested in the adjacent and the hypotenuse, we use the cos function. We say cos of the angle theta is equal to the adjacent, which is what we're trying to represent, divided by the hypotenuse, which is u. From here, you can multiply both sides by u to get that u cos theta is equal to the horizontal component of the initial velocity, uh. And from there, we can say that the horizontal distance that's traveled is u cos theta multiplied by t, or ut cos theta. That's as far as we can go for now, and because this is the horizontal displacement and it wants it as x, we can actually just replace this as x to make it even easier. We didn't even need to include this, honestly, because it wants it as x, so I guess you can just replace it with x. That's the equation for x. Let's now represent an equation for y. Again, let's change back to green. So for y, we have to look at the vertical part of the motion, and that's where the acceleration is dependent on gravity. Initially, it's going upwards, so that means it's going against gravity, meaning the acceleration will be minus 9.81. Or, I think earlier in the question, sorry, I cut it off, but it says assume acceleration is equal to 10. In that case, a is going to be minus 10, because it's going upwards in this case. Using SUVAT then, let's break this down. S is the vertical displacement that's traveled, so from the origin to this point here, the vertical displacement is going to be y. U is going to be this vertical component now. How do we find the vertical component? Well, we can use the opposite and we can use the hypotenuse, and we can say that sine of the angle is equal to the opposite, which we're trying to find. Let's call that uv for the vertical component of the initial velocity. So uv all divided by the hypotenuse u. What that means is we can now represent the vertical initial velocity by multiplying both sides by u and getting u sine theta equals the vertical component of the velocity. So let's replace the initial velocity with u sine theta. By the way, u still comes from that initial speed that it tells you that it's projected with. What else do we have? Well, we have acceleration is minus 10 because it's going against gravity, and we want the equation in terms of t. So we're just going to write t as t here. So which equation links s, u, a, and t? Sorry, I didn't write out the SUVAT equations here, but it's s equals ut plus half at squared. Let's substitute into that. S is y equals ut, u sine theta times t, so that's ut sine theta, plus a half of a. A half of minus 10 is minus 5, so let's write minus 5 t squared. And that's it, and that's x and y. Let's highlight all these important equations, by the way. So we have, this is the equation for x in terms, okay, I don't like this color. Sorry, you'll see me change colors quite a lot. This is the equation for x in terms of t. This is the equation for y in terms of t. It then wants you to find the Cartesian equation. What's a Cartesian equation? It's an equation where the variable that links x and y That's gotten rid of. In this case, you want to replace t so that you only get an equation in terms of x's and y's. In this case, it's easiest if you replace t by making t the subject of this equation. So t equals x over u cos theta by dividing both sides by u cos theta. And then substituting that into the other equation, because what it will mean is that all the t variables are gotten rid of and you only have an equation in terms of x's and y's, which is what you want. So let's do that. Y, we're going to leave it as it is equal to u sine theta multiplied by all of this, t. So let's write this out. U sine theta times x over u cos theta. And then minus 5 lots of t squared. T squared now is the square of all of this. When you square a fraction, you're squaring the numerator and the denominator. So it becomes x squared over the square of the denominator, which is u squared cos squared. U squared cos squared theta. Now here, it does help to cancel out. So u cancels out with this u on the denominator. Sine over cos is tan. So we can write this as y equals tan theta times x, or x tan theta. And then minus 5 over u squared cos squared theta, and then x squared. That's an equation in terms of y and x because the variable t now is gotten rid of, and this is your final Cartesian equation for this curve. Great. I'm going to erase some of the working out just so you can have a look at the question while I do the rest of it. And I'm just going to move this answer because I'm sure it'll be useful later on in the question. Well, actually, I know it'll be useful because I did the question beforehand. And yeah, let's have a look at part 2 as soon as I remove some of this work now. Okay, remove a bit more. Okay, perfect. Let's now have a look at part 2. A player in a cricket match throws the ball with a speed of 30. Okay, so straight off the bat, it's told you now that the initial speed u can just be replaced with 30. Let's write down as much information as we can extract from this question to another player who's 45 meters away. So if two players are 45 meters away, that's the horizontal distance between them, or what we introduce as x. So we can say x is equal to 45. Assume that the players throw and catch the ball at the same height above the ground. That's important. If they start at this height and they end at this height, the vertical displacement y is going to be 0, because displacement by definition is the distance traveled from the starting position to the ending position, and vertically there is no distance traveled. There is no displacement because it starts and ends at the same position, meaning y is 0. Show that there's two possible trajectories. How you show that is you want to solve for theta, and you want to show that there's two different values of theta. By the way, two equations that I accidentally rubbed out that we formed, I'm just going to write them out one more time because they are useful in this question. X equals ut cos theta and y equals, I believe it was, yeah, I just have it written down here, x tan theta. I'm sure it will be important in the, at some later stage. So 5 over u squared cos squared theta, all multiplied by x squared. Perfect. Okay, if you want to find the value of theta, let's start by substituting into the y equation. Let's see if we can solve that. So when you put it into the y equation, we replace y with 0 is equal to x tan theta, so 45 tan theta. And then take away 5 over 5 times x squared. So 5 times, we have the value of x is 45 squared, all over u squared. So u squared is 30 squared. And then cos squared theta. So straight off the bat, it looks like we are going to end up with a trig equation that we can solve. So yeah, let's simplify. First of all, I'm going to replace tan with sine over cos because it looks like you have to use the cos in some format. So let's write 45 sine theta over cos theta. And 5 times 45 squared over 30 squared actually is just 45 over 4. So let's write 45 over 4 cos squared theta. And then to make this in a format where it's easy to solve, I'd recommend you multiply every term by cos squared theta. So let's do that. Cos squared cancels out with one of the cos on the denominator, leaving you with just 45 sine theta cos theta as the first term here. Sine theta cos theta. This cos squared cancels out with this cos squared, leaving you with 45 over 4. So minus 45 over 4 is all equal to this side here, which is 0, because 0 times cos squared theta is just 0. Moving on now, how do we solve this for theta? Because that's what it's asking for. It wants us to show that there's two trajectories. which is we can do by showing that there's two angles of theta that it can be projected from, if that makes sense. Well, I think the easiest way is to start by multiplying everything by 4, so each individual term by 4 to make it easier to solve. So 45 times 4 is actually 180. So 180 sine theta cos theta. The times by 4 and the divide by 4 cancels out here, leaving you with just 45 for the second term equals 0. Now, you may have cleverly thought, oh, 2 sine theta cos theta, isn't that what double angle formulae are? And yeah, that's true. So you can separate this into 90 times 2 sine theta cos theta. If you'd like me to make a video about double angle formulae, just do let me know. And the reason I separated it like this is now we can replace this with sine 2 theta. And we can say 90 lots of sine 2 theta minus 45 is equal to 0. And from here is finding the value of theta. So add 45 and divide both sides by, okay, let's take it step by step. We'll start by add 45 to both sides. Equals 45. Divide both sides by 90. And actually, 45 divided by 90 is just a half. We can then do the inverse sine to find the values of 2 theta. So inverse sine of a half is, well, it's equal to 30 degrees. But there's also a repeating factor, and that's where that second trajectory comes in. The reason for that repeating factor is the fact that we know the sine curve. If you find a value like 30 here, we know because of its symmetric nature that 30 away from 180, there's another solution that's also equal to that y value. 180 take away 30 is 150, so the other solution we can write as 150 degrees. And those are your values of 2 theta. To get the value of theta from there, you want to divide both of your solutions by 2, and you get 15 degrees and 75 degrees. And those are your two possible trajectories. We pretty much shown it by actually finding it, so yeah, that's fine. Honestly, there's quite a lot of work for 4 marks. It should be more marks, but what can you do? Describe briefly one advantage of each trajectory. So the 15 degrees ones means that it's going to look more like this, with the angle above the horizontal at 15 degrees, and the 75 degree ones is going to look more like this, with this angle here being 75 degrees. The advantage of it being 15 degrees is it'll be faster because the horizontal component would be faster. The advantage of 75 degrees is if there's any overcoming obstacles, it can overcome it. It's more likely to overcome it. So more likely to overcome obstacles. So yeah, do you guys want to let me know in the comments how you found that question? But yeah, hope this video did help. If you want more A-style level videos, I think I have a whole playlist underneath, so be sure to check that out. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website, www.excellineducation.co.uk. It's on the first link in the description too.